now live streaming after me. Very good. Maybe have a second one. So people can hear me.
还有网友们大家，真的来，
老师怎么说的
OK 好可以的，你们要跟他说老师好慢点，之前都还是记得。
我刚才想看到那条河一下有点晕的。
So even though the coral reef ecosystem wasn't specifically highlighted in the framework, but 16 out of the 23 targets are highly relevant to coral reef and its associated ecosystem. From the spatial planning, protected area, and also pollution and climate change. So during these 2 weeks, the parties will be established in the monitoring mechanism, hopefully. And how do we integrate the coral reef and associated ecosystem into MBSAP to support the alignment of the parts, plans and target? And these are the questions we have to address. But the thing is for sure, that is we can't do this without each one of the sector and everyone. So even though like it's merely the 4th day of the COP, but I already see so many travel all the way to Cali, Colombia to discuss with us. And we invited the people and the person online to join us the discussion. And the session will begin by a 40 minutes keynote speech and followed by a 30 minutes panel discussion and then 10 minutes Q&A session. Okay, so all right, let's begin. So first our speaker is Professor Chang Feng Dai from NTU's Institute of Oceanography. Professor that has over 40 years experiences specializing in evolutionary biology and marine biology, and he dedicated himself into the coral education and also the coral restoration and conservation too. So Professor Dai is going to share with us about the overview of the coral reef in Taiwan, and also without further ado, Professor, the floor is yours.
Thank you, Cleo. And good morning, everyone. Yes, I started my work in on coral reef ecology in 1979, and so it's more than 40 years. I have been the representative of Taiwan for GCRMM from 1996 to 2012, I think. Okay, okay. In this talk, I will briefly give an overview of coral reef in Taiwan and the specifically contribution of Delta Foundation on coral reef conservation. Okay, so I have to manage by myself.
It was totally working like 5 minutes ago.
Sorry. Okay, start here. Here. Taiwan is a small island located in East Asia, lying between the Philippines and the Ryukyu Island, Ryukyu Archipelago, and between tropical and subtropical regions. Due to the influence of cross-shore, the marine environment of Taiwan is favorable for corals, and very high species diversity and coral fauna can be found in, including soft coral and hard coral can be found in waters around Taiwan. This coral is widely distributed in northern, eastern, and western Taiwan, southern Taiwan. The west coast of Taiwan is mainly sandy and muddy coast, and the it's basically no coral except on the hard structure of breakwater. The distribution of coral in Taiwan show a very steep gradient of species diversity. In southern Taiwan, you can find 400 species hard corals, 200 species of octocoral, and the coral cover is about 35%. In central part of Taiwan, you can find around 200 to 250 species hard corals and 100 species of octocorals, and the coral cover is around 35%. In northern Taiwan, the species diversity reduced to about 120 species, and the coral cover is relatively low. This line delineates the subtropical coral community and the coral reefs. Above this line, there's no reef formation, only coral reef. We usually call it marginal coral reefs. Below this line, including southern Penghu, east coast, and southern Taiwan, there are coral reef, extensive fringing reef or patch reef in eastern Taiwan. Okay, this slide shows the most recent survey of coral reef in Taiwan. In 20, sorry, it's wrong. This one, this figure shows the typical coral community in Taiwan. In southern Taiwan, the species diversity is very high. And in this figure, you can find more than 30 species, and the coral cover is also very high. In central Taiwan, the species diversity is moderate. The coral cover can be high, but only dominated by few species. In northern Taiwan, the species diversity and coral cover goes low. This figure shows the most recent status of coral reef in Taiwan. Dr. Tong Yun Fan did a survey at 7 localities. Each locality had 4 to 6 sites surveyed. Here is the summary of the result. In southern Taiwan, the coral cover, hard coral is about less than 30%. Xiaoliuqiu is less than 13%. And the total average about 31%. This number is basically higher than the average of the world. If we look at if we evaluate the health of coral reef by coral cover and the percentage of the ratio of coral and algae, and then most of the reef in Taiwan are either stable or healthy, but some reef, the coral site, reef site in Xiaoliuqiu are either disabled or degraded. And about half of the reef site in southern Taiwan and northern Taiwan are degraded. These are the areas of the coral restoration are needed. Xiaoliuqiu, northern Taiwan, and southern Taiwan. It has been documented that global coral reef started to decline since 1960s. Okay. The causes of coral reef degradation include human impacts such as overfishing, sedimentation, eutrophication, and over-tourism, as well as global climate change, especially ocean warming or heat waves, which often cause mass coral bleaching. Mass coral bleaching was first reported in 1982, then more severe bleaching occurred in 1998. At that time, global coral cover had reduced to about 36%. Since then, more frequent mass coral bleaching occurred globally, and coral cover declined to 19% in 2018. However, such a decline of coral cover is not universally equal. In some areas, it's most severe, for example, in the Caribbean and Papua New Guinea. And some regions even show increase in coral cover. For example, the northern West Pacific, some increase in coral cover. Mass coral bleaching in Taiwan, there are 3 major events. In 1998, almost all coral community in Taiwan suffer about 70 to 80% of bleaching. Most of them recover after sea temperature return to normal. And the mortality was around 25 to 33%. The second mass coral bleaching occurred in 2020. It was also widespread. About 70 to 80% of coral bleached, while the mortality was lower, about 10 to 20%. This year, coral in Taiwan also suffered severe bleaching, as most bleached areas were impacted by strong heat wave in summer. However, coral bleaching was sporadic, and some preliminary surveys showed that the mortality was less than 10%, partially due to the influence of typhoons. This trend demonstrates that the adaptability and resilience of coral community in Taiwan. So, how corals in Taiwan are doing better? Several studies have demonstrated that main feature of coral reef community in Taiwan. Firstly, super reef. These reefs are suffer thermally stress, but alleviated by periodic upwelling of cold water driven by strong internal waves. Second is sugar corals. These corals survive long-term or periodic thermal stresses, such as those in the outlet of a nuclear power plant in southern Taiwan and in the tidal area of Penghu Island. The third one is coral refuge. The subtropical environment of northern Taiwan can be regarded as coral refuge, as this region can provide habitat for tropical corals. In fact, we have seen Centro National Park and southern Penghu Marine National Park. The NGO include Delta Electronic, Taiwanese Coral Reef Society, etc. They are actively involved with coral reef research and conservation, public education, and also coral restoration. The contribution of Delta Electronic mainly focused on four major issues. First one is monitoring of the health coral reefs by Coral Watch, Coral Net, and 3D modeling. Delta Foundation has trained many volunteers to conduct the monitoring of coral reef at various locations around Taiwan using the above method, particularly focused on the application of coral net and 3D modeling. The second, coral restoration for the degraded reef, mainly at the reef island of Xiaoliuqiu. The third one is boosting coral refuge by restoring coral farms in northern Taiwan, or exploring the thermal resilient corals through sexual and asexual protocols. Delta Foundation established the Coral Conservation Center in cooperation with National Museum of Marine Science and Tropical Technology in Hilo City. In this center, more than 3,000 small fragments from 20 more species were cultivated. These small coral colonies were then transplanted to selected sites and constructed coral farms to facilitate the formation of coral ecosystem. These coral farms will provide additional substrate for coral larvae from the south to settle and can act as coral refuge for tropical species to survive under the impact of climate change. As you know, reef and Xiaoliuqiu suffer the most severe degradation. To facilitate the recovery of coral community, and with the support of Delta Foundation, Dr. Tung Yunfan studied coral restoration at this island in 2022. Coral fragments from nursery site were transplanted to reef blocks, and after 12 to 33 months, the coral covered the whole area and grow very well. Dr. Fan will expand his experiment and to facilitate further recovery of coral reef in Xiaoliuqiu. Finally, starting from 2022, Delta Foundation support the exploration of heat resilient corals through sexual and asexual reproduction. The asexual method was mainly done through the proliferation of coral survived heat waves or heated effluent from a nuclear power plant by fragmentation and coral gardening. Then tested their survival rate and heat tolerance capacity with an aim to select heat tolerance corals. The sexual reproduction method was conducted on both brooding and broadcasting spawning corals. For breeding coral, Dr. Fang worked on Pacífico acuta in southern Taiwan, and Dr. Guo worked on Stylophora picella in northern Taiwan, and also Dr. Wang worked on spawning corals. For details of this experiment, I'm not going to elaborate. Please go to our IUCN Pavilion this afternoon. Okay, thank you.
Thank you so much, Dr. Dai, for giving the overview of Taiwan's coral reef ecosystem and also how Delta is using the different kind of approach to deal with the current challenges. And our next speaker is Dr. Jason Spavaro, the staff scientist and program manager from Mote Marine Laboratory in Pavilion. And Dr. Spavaro research focused on the landscape scale of the restoration in Caribbean coral reef, and also focusing on how his work is involved with manipulating ecological process such as grazing to facilitate and support the restoration and recovery of coral reef. And without further ado, Dr. Spavaro, the floor is yours.
Thank you. Thank you.
Thank you. I'd like to talk about integrating citizen science and expanding the scope of doing restoration beyond just scientists and practitioners, particularly in Florida where we're based. So Florida's coral reef is the third largest barrier reef ecosystem on the planet. It stretches 563 miles from St. Lucie Inlet, kind of in the central part of the Florida Peninsula, down to the Dry Tortugas National Park, which is about 70 miles west of Key West. And historically, along that 563 mile long, or 563 kilometer long reef tract, there was roughly 60% coral cover over many fewer species than in Taiwan, with about 64 species of Scuttertinian coral across that space. Unfortunately, similarly to elsewhere in the world, over the last 50 years or so, we've had a dramatic shift in the ecological character of that ecosystem. Something like 60% hard coral cover and true coral dominance back in the 1960s and 1970s, to something closer to 2% coral cover, and taxonomic dominance of species such as octocorals, sponges, and macroalgae in the current time. That's made restoration and coral gardening, coral farming, and active restoration interventions absolutely ubiquitous throughout the region as not just a barrier to the loss of biodiversity, but as a primary management scheme to maintain these ecosystems and their services. A lot of that has focused on the production of Acropora, the two species of Acropora that we have in the region, and one hybrid, but also the massive form boulder brain and star corals that are much slower growing, much more difficult to do at scale, with the idea of outplanting hundreds of thousands of millions of these corals over the course of decades, and then overcoming some of the Lee effects so that reproduction and sexual reproduction jumpstarts these natural processes in downstream recruitment, and takes over the job of restoration. But scientists can't do all of this work. There's too much of it to do. So you have to integrate with partners locally and internationally, but also partners that actively conduct the work of restoration. So at Mote, we've partnered with a diversity of different groups to execute this mission. Scuba Pro, the commercial dive gear manufacturer, has partnered with Mote Marine Laboratory in a program that brings recreational divers to the Florida Keys at our headquarters there. And those recreational divers receive a couple of days of intense training with our staff and practitioners, and then both participate in the production of coral, and then actually the physical outplanting of those corals, and then the monitoring thereof. The trips have been a fantastic success. We're trying to expand that program to include more and more and more. It's not just, it's much less valuable as an actual intervention and much more valuable as an outreach education tool to get that message and create these ambassadors and stewards of the environment from all over the country. Similarly, there are other groups that are much more focused on actual implementation, such as the Combat Wounded Veterans Challenge. And this is a group of gentlemen who were military veterans who were wounded in combat and now are giving back to philanthropic and environmental causes, such as partnering with Mote Marine Laboratory. And this group, despite missing limbs and having other wounds that are much less overt, were able to outplant over a couple of different visits more than 5,000 coral fragments on Florida's coral reef. And in fact, 1,000 fragments in a single dive last year, right just before the heat wave. And then those corals that they outplanted showed a 60% survival rate through that worst and longest heat wave in history. And in fact, their production prowess is amazing as well. They were able to create 2,000 microfragments across 8 different species of coral in a single day. So they're, despite missing limbs, they're running circles around my staff and me. And here's just kind of an illustration of some of that, where they're dealing with challenges, and their motto is one that's very inspiring. It's Vulnerable non vincor, which is wounded but not defeated. And it's very apt for the reef, where the reef is absolutely wounded, but it's not gone, and we are focusing on that resilience and recovery effort and integrating folks that are dealing with similar things in their lives. Other programs are more focused on monitoring and surveillance. So Mote has a program called Bleach Watch, which is modeled after the Great Barrier Reef's Bleach Watch program, where recreational divers come and do some training with Mote staff, and then go out and collect data on their recreational dives throughout the year, which allows for surveillance and monitoring of bleaching, paling, and disease incidents across a much larger spatial scope. And then those data are returned to Mote through this portal and generate reports that go out to not just the participants, but also stakeholders and managers throughout the region, which details obviously the data on NOAA bleaching conditions using sea surface temperature data, but also on the actual observations of bleaching stress and the extent of it throughout the region. Finally, we engage and communicate the science that Mote scientists are doing directly to the public through Mote's public aquarium. And we're thrilled, even after being hit very hard with Hurricanes Helene and Milton, that in the next few months we'll be opening Mote's brand new state-of-the-art Mote Science Education Aquarium, which obviously is a place where Mote can display and communicate the science that our staff do. But also it is geared specifically to science education. So there are STEM classrooms and workforce development programs that are built directly into the facility and are aimed at fostering that next generation of stewards and scientists, but also building the workforce for these jobs for tomorrow. And thank you.
Thank you so much for Dr. Spinaro for such a wonderful, amazing introduction about the Mote, and specifically about the Wounded But Not Conquered program. I think it's really meaningful. Thank you for that. So later, I'm going to pass over the microphone to our next speaker, Mr. Wing Zhang. And Win is the CEO of Delta Electronics Foundation. He's the key person to initiate Delta's coral restoration started from 2019. Win himself, despite how busy he is, he still goes diving like every weekend and reminds us the ocean surface temperature persistently and reminds us regularly. So welcome, Win. The floor is yours.
Thank you, Claire, and a big thanks to Professor Dai and Jason, just for they are both the either quite important partner for Delta Electronics Foundation. And I believe today here everybody for our audience they are all tuned up for coral in this weather. Some of you maybe in the tech boat to here. So I just will say my thankfully for this. And this, oh, sorry. This year marks the Delta Foundation's first participation in as an observer in a convention of biodiversity. However, in the past, actually we have participated in another code, UNFCCC, which was for climate change for 70 times and hosted 26 side events and booth exhibitions. So you might have some questions that Delta Foundation, for the traffic arm of the electronic company, is hosting a session on coral. Indeed, our focus has always been addressing the current crisis on global and local scales, and this was primarily done by promoting green buildings, energy efficiency, and low carbon transport. However, we are seeing an urgent needed to address the impact of climate change on our ecosystems, as we are already getting close to the 1.5 degrees Celsius warming threshold. Till today, I believe it's 1.62 degrees Celsius compared to a pre-industrial period. 2020 was the most severe year for coral bleaching in Taiwan today, with estimated 40% of the corals completely bleached. And a Delta engineer who is enjoying for scuba diving, who is currently work for the Delta, we call it ICTBG. This means he is responsible for AI server liquid cooling development. Send the picture, this picture, to Foundation, and he want to tell us how was the situation under the sea for the bleaching corals. And this made us realize that beyond promoting energy saving technologies, we also need to raise public awareness about the impacts of global warming and explore potential adaptation technologies. Welcome. And since that year, the foundation has gathered the engineers found within the companies. Many those already scuba certified, and to work alongside researchers from two North and Southern Taiwan marine museums to learn a coral reef health survey techniques. And these engineers who might typically be developing the power chokes in your mobile phones, DC converters in your electronic vehicles, and or if you ever heard of that solid state transformers in a power grid. They are all these kind of engineers, but they just take one role when they are under the sea. They are the volunteer of coral restoration workers for the foundation. And we coordinated with various researchers institutions to have the engineer volunteers learn, such as the CoralNet technology developed by the UCSD to assist scientists in conducting coral habitat survey. They were also trained to identify different types of corals and to help scientists collect coral gaming bundles. This year, we also sent them to Malt to work with Jason's team, where they learned how to establish coral nurseries, rescue bleaching corals, and build 3D coordinate systems. According to NOAA's data, Taiwan was initially expected to experience another severe coral bleaching event this year. Fortunately, a few typhoons arrived, slightly lowering the water temperature. However, like in Florida, typhoons and hurricanes, just like a double-edged sword. While they can stir up the hot seawater to relieve heat waves, they can devastated the coral nursery overnight. This is also what we are currently learning to address. The Delta Foundation has currently established two coral nurseries and one conservation center. The two nurseries are located in Kenting and Chaojing conservation area, about 500 kilometers apart, one in tropical waters and the other one in subtropical. The nursery in the south focuses on cultivating heat resilience corals, as the area experiences year-round warm water, just like the Professor Dai said, discharged from the nearby power plant, combined with the cooler deep sea water brought in by the tides. As a result, several coral species here have developed higher heat resilience than others after the power plant was established. The main focus there is cultivating, we call it lens coral, with 12 other coral species being tested. After the significant breaching event this year, the survival rate of these corals is around 14 to 16%. The other restoration nursery experienced winter sea temperatures as low as 17 degrees Celsius, which is theoretically not ideal for coral growth. However, due to the effects of ocean warming, just like Professor Dai said, it's like the coral refugees. The number of wild species is increasing. So in recent years, the summer temperature in this area have also reached above 33 degrees Celsius. Therefore, we are focusing on restoring heat resilience species, the local ones like the hood coral, and other species that have shown less noticeable bleaching over the past 4 years. Additionally, we have collected gaming bundles from coral species that have recently experienced significant bleaching for research on heat resilience corals. We also collaborated with a museum to establish a coral conservation center next to the Chaojing conservation area. Utilize Delta's LED and automated control system in the coral tanks. The Centro focused on 107 species listed as vulnerable or endangered by the IUCN in Taiwan. These species are being used as indicators for seed collection and active conservation. At the same time, Delta's micro-CT technology is being used to create a coral skeleton database. This conservation center also serves as an education base, and in addition to other volunteers, we also recruit land-based volunteers and works with a museum to allow students to experience coral restoration work, just like the model did in Florida. And underwater volunteers then will plant the corals in the nurseries. Before Delta's involvement, the two marine museums we partnered with had already established life under stream systems. That means it's which allow the viewers to watch an underwater stream on YouTube. Can I mute it? Okay, awesome. Okay, this year we put 4 more. We just have a live stream stand underwater for 20 meters and try to let more people understand. Even the bleaching is quite serious in Taiwan, but corals are still fantastically struggling to find a way to survive. We understand that it doesn't work. No? Okay. We understand that many international funds have already been invested in coral restoration, and as a foundation, we are established by a single corporation. We might not able to do as much as others. Still, we can leverage Delta's technology and this unique group of engineer volunteers to continue contributing to coral restoration. This also aligns with the original mission of the Delta Foundation, which is use technology to mitigate and adapt the impacts of global warming on biodiversity. I will explain more of the technical details during the IUCN Nature Pavilion session at 12:13 p.m. And we can discuss them during the panel discussion later. Thank you.
Thank you, Mr. Zhang, for showing us how the technology deployment could also restore the coral. And last but not the least, our one of also like very special guest speaker here is Dr. Guofang Zhong. Dr. Zhong is specializing in plant systematic and biogeography. His interest in specialty lies in studying biogeography, population genetics, and evolution from the context of the phylogeny. Dr. Zhong, over to you.
Thank you very much for the invitation by Delta Foundation. I think one of the reasons I'm here is because I'm now the president of the SWAN International Society for Nature and Wildlife and Nature Taiwan, and we have SWAN has participated in CBD since 1992. And but I am not a coral scientist, so I really know nothing about coral. But I'm a plant taxonomist, and I don't know if you guys know that up to 19th century, coral are considered plants. So I don't think I'm in the wrong place after all. Okay, and I need to give credit to Dr. Zheng Minxiu, my colleague at our institute. And before I came to this talk, and I approached him, and he actually. We discussed what should we talk about during this panel, and he actually asked me to, if I can bring the attention of the really ongoing crisis of coral in Taiwan and actually across the Western Pacific, which is the outburst of the crown of thorn starfish in Dongsha Island, basically, but actually across the whole region in Taiwan. Yeah. And as Dr. Dai had mentioned, that we have a Dongsha Atoll National Park, which is actually the first marine national park of Taiwan, and this is a very, very biodiverse region. And so it's actually quite far away from Taiwan, as you can see that. It's a very beautiful atoll. I have the opportunity to visit there twice. Okay, and in the Dongsha Atoll, they actually have recorded 383 corals in the region, very, very high diversity and a very, very high coverage. And in old days, this coral is very healthy and with a very, very diverse marine biodiversity. But this is what's happening at the moment in 1922. This year, 2024, they noticed an outbreak of this starfish called, the name is called crown of thorns sea star, and the scientific name is called Acanaster. The taxonomy is still debating. And based on a recent study published just a few months ago in Marine Biology, based on DNA sequence analysis, there are actually at least 5 different species of this sea star across the world. And in the one in Taiwan and also including the Western Pacific, it's likely called Acanaster solarius. And as you can see from this green star, it's very, very widespread. And they have a very, very high density in the reef in the coral reef in Australia, and this is where the scientists first noticed the outbreak of this sea star. Okay? And so this is what the sea star looks like. It's actually quite thorny. It's actually quite frightening. This sea star can grow up to 80 centimeters in diameter, and this is very thorny. And these thorns are actually poisonous. So if you got bitten, it's actually quite lethal. Okay, and this sea star used to be occurring in Taiwan in relatively low density, in all early surveys, probably find one individual per hectare. And but since about 2010, Dr. Zheng Mingxiu, he noticed the increase of number of these sea star in Penghu, and he immediately mobilized a local volunteer trying to remove them manually, and that actually controlled the outburst of this sea star in 2010. And back then during the pandemic, during the COVID pandemic, and he noticed that after 2 years of because of the COVID, he couldn't die survey in central of Taiwan. And there's a very small island called Taiping Island in South Pacific, South China Sea. He noticed an outburst of this sea star, and more than 90% of the coral basically eaten by this sea star. As you can see, that they basically just eat everything. And so this shows that they actually eat like not only stone coral, it's soft coral. And Dr. Zheng even noticed that some of these sea stars, they eat the sea turtles. So they basically eat everything in the ocean. Okay, and so why we have this outburst or of this outbreak? One basically scientists, probably Dr. Dai can actually can help me with that. We still don't know exactly why this happened. There's many explanations. Many people trying to solve this issue, but this is a really serious issue. But one of the major predator of this sea star, nature predator, is this called Triton's trumpet. It's a very highly treasured shell. It's one of the most beloved shell. It's a very high market price. And this shell actually they can eat the sea star, even though the sea star is huge. They can even eat it. They are not really afraid of song and stuff. But this shell is extremely rare now, and there's a very huge challenge to trying to artificially breed this shell. So this actually probably is one of the major reasons why there's no way to naturally control them. Okay, so in Taiwan. Since the discovery, the detection of these outbursts, Dr. Zheng and a lot of volunteers are trying to remove them or to kill them. And now there are actually only 2 ways to kill this animal. So first is they have to use, this is a special squad, they're trying to inject about 2% of the acetic acid into the sea star, they will kill them. And they won't really cause any contamination in the ocean, or you have to manually remove them. So it's actually very challenging task. And this this shows that these volunteers, they in a single dive of a single cylinder dive, they can cause this much. But there are now thousands of millions of these stars devastating the coral reef in Dongsha at the moment. And so actually the council, Marine Council, they actually mobilized about 100 volunteers trying to remove them. But it's a very difficult challenge. And so I think one of the most important messages is that when we talk about the healthy of coral ecosystem, climate change is one of the issues we focus on mostly. But the most important thing is a healthy ecosystem. If the ecosystem is healthy with a lot of diversity, different predator present, so this is probably one of the most important things is to keep a very healthy, diverse ecosystem so that we can really control this outburst. But I think there's an irony because the sea star is not an invasive species at all. It naturally occurs in the region, and it's because of a lot of ongoing reason behind this. And so this is a very complicated issue. But I would like to using this opportunity to bring you guys attention of this very serious issue. And when you just mentioned the technology, I was thinking if you can try to use AI to design a robot, and we can automatically inject this acetic acid into this.
Australia already has.
Yeah, I think Australia is already do that. But we Taiwan have much better technology, right? We are very strong. We have the NVIDIA chip produced in Taiwan. The TSMC can help us to build a very efficient robot. This might be the opportunity to really let the high-tech companies engage in this very important task. Thank you very much.
Thank you so much for Dr. Zhang for such inspiring and insightful speech. So now we are moving forward to our panel discussion. So let's welcome the four speakers to come on stage. So my first question is for Dr. Spadaro. I'm wondering, like after COP15, how is the mode, research direction, or citizen science programs you just shared influenced by the international framework like KMGPF?
Thank you. I'd say that one, it reinforced our mission to aggressively restore function and form to Florida's coral reef, but then also to engage in international partnerships and share those technologies and successes that we've had, and then also learn from likewise across in different oceans, like with Delta Electronics Foundation and the National Aquarium in Taiwan, but also with groups in throughout the Caribbean and Mesoamerican Reef, the Red Sea, all over the world. It also has highlighted some of the bottlenecks to achieving the 30 by 30, which is namely funding, where our funding is increasing, but not nearly at the rate that the demand for restoration and success has been increasing. So it's also driven a major shift in MODE's research objectives towards efficiency. Not just in the efficacy of the interventions that we're executing, but also in the cost and labor and material efficiency of doing them. So that has become a fundamental component of our research strategy, is doing more with the same or slightly more than we've had in the past. So every dollar that we use to do restoration needs to go further and further and further, and that's been driving quite a bit of innovation from the ground up.
Thank you so much. I think Dr. Sparrow, you just highlight the efficiency and also how we are going to go forward from the COP15 global agreement will influence the research. And it's kind of like tap to my second question. And my second question will for Dr. Zhong. Dr. Zhong, I would like to ask, how can we best translate science into physical action, and what are the key factors to effectively implement the KMGPF, other than the Dr. Sparrows mentioned, the efficiency and technology?
I think that's a very, very tough question. This is, I think everybody try to ask. I Google it. Actually, in clinic practice, the question is known as what we call implementation science. And so this is a scientific study of method translating research finding into practical useful outcome, which is contested and complex, and with unpredictable use result from routine clinical practice and different levels of continuing assessment of an implementable intervention. So there's no short answer to this question. So I think it's just a very big challenge. But I think as for the biodiversity conservation, I think the most important thing is just to let people know what is biodiversity, which I think a lot of people still don't know why this is very important, and why that biodiversity is important, and what is the biodiversity crisis we are facing now, and what are the consequences of biodiversity loss. And that is mainstreaming biodiversity. I think mainstreaming is still very, very much an important thing. And then I think the feasible action really depends on the context of biodiversity mainstreaming. I mean, different area, different country probably have different degree or extent of mainstreaming. So I think that all the policy actually really depends on how people accept understand the biodiversity crisis. And so we can really, this is important when we make any policies. I think this is a very important background information. And as a scientist study plant diversity, I think my team, our primary responsibility is really to provide an accurate and timely data for relevant to biodiversity conservation. and really report and distribute this finding as widely as possible. And so that's why in Taiwan we really focus on the open data. Basically, we have to just open our findings as much as possible. So in Taiwan, I'm personally in charge of several national biodiversity database, including TaiCo. We maintain the most updated checklist in Taiwan, and since the checklist is foundation for the basis for everything, and we collaborate with Professor Duanmu's team. We have maintained TaiBeef. Maintain a TaiBeef, which is very successful, and also TaiBeef incorporated the citizen science data, so we can have a very good data of the current situation or the distribution of all the species. And also we have TaiEOL, Taiwan Encyclopedia of Life, provide the public the most updated information about our biodiversity. And we also have TaiBone. TaiBone is really an observatory network. And so this information, when it's open, it's accessible, it provides the government with a very useful information to plan better the conservation strategy. And I think, lastly, I think very important is now there's a lot of people, especially the private sectors and the big companies that are interested in biodiversity. So I think we should try our best to really leverage this energy to do this. But in the past few months, I actually had the opportunity to talk to a lot of the business. I got invited, and they always, when I talk about, I think we do very good with mainstreaming. People can understand the important biodiversity, but they don't know. They will ask me what to do next. What to do next? And I think now, if we can provide a better, really a very good plan, strategy. And what here I want to mention that, for example, in Taiwan, the Forest Bureau, they actually have established a very specific guideline for OECMs that let the enterprise, the business can help with the OECM. And that's a very clear guideline. And also they have a platform that you can try to match up some SDG actions with, so the business actually they want to do SDG, ESG, they actually have a way to do that. So I think this is probably too long, because this is very complicated issue. Okay?
Thank you so much for the highlight about the data.
And second is for how to effectively implement the Kunming Montreal. I think basically it's the same thing. Is very importantly, I think we, for example, in Taiwan, we need to have a better, actually based on our current, the degree of the mainstreaming, the government have to come out with an MPSET as soon as possible. I think that's very important. We have a better guideline, and so that we can, a lot of policy can really be developed. And I think the only, based on what we know and all in the midst of this biodiversity crisis, when we have a good MPSET, I think that every sector, like the academia and the government and the private sector, business, we should mobilize all the resources to implement that. So that's $1 trillion question, right? But I think we know the answer. I think we know the answer. I see the GBF actually can provide a very clear guideline, a target what we should do. And so if the government is willing to really make this GBF into an MPSET, I think that is something we should all work together. Thank you very much.
Thank you so much for the insightful, and I think Dr. Zhong also highlight the OECM, and that's also contribute to what we are talking about, like 30 by 30 now, and the data could include it in together to see, to identify and to help like different stakeholders. How do you identify the next biodiversity hotspot? How do we do, and what's the next step? So that will lead my questions to Dr. Dai. It's a question I want to ask. When we talk about 30 by 30, people tend to neglect the interlinkage between the terrestrial and the marine ecosystem. So what kind of the approach and strategy should we take to ensure to restore and conserve the coral in a holistic way?
Yes. Most of the impact of coral reefs coming from terrestrial environment. originating from land, such as sedimentation, from terrestrial runoff, sewage pollution, trash, and plastics. So when we establish marine protected area, we need to consider the management and protection of adjacent terrestrial environment. This approach is known as ICZM, Integrated Coast Zone Management. Okay, so conservation of this conservation and restoration of coral ecosystem also need to consider this impact, the impact from terrestrial environment, and this should be the first priority. Only when the impact from land can be reduced or controlled, the success of coral restoration and conservation can be.
In coral nursery to accelerate the reef restoration strategies.
Oh, thank you. So we're fairly established in the way, and we're fairly good at putting corals back onto degraded reefs. It's identifying which corals are going to do best and what aggregation of different resilient and resistant and genetically diverse traits we want in that, or well, we should have in that restored community to then take over essentially larval supply for downstream areas and then restart those recruitment patterns. But in order to do that, we have to have appropriate settlement habitat and appropriate ecological interactions for, to avoid competitive interactions where we're hoping for those propagals to land and establish. So adjusting herbivore algal interactions is obviously not as sexy, I think, as active restoration of corals, although I take it back. I think it's way more interesting and exciting, but it is also very critical, and you can absolutely marry that up with, for instance, I work with a large herbivorous crab that consumes algae and facilitates coral survival and we think the recruitment and settlement of coral larvae. Integrating that into our restoration strategy not only provides for the maintenance of our coral garden, we're getting rid of the weeds, or at least kind of mediating the interaction between the weeds and the coral, but it also prepares the habitat for coral larvae and settlement. There's all kinds of knock-on effects where this does become kind of a larger picture where, some of these herbivores that we're working with, obviously can be bioeroders, so we need to be careful in that. Some of them are valuable as food products, so there's space for this to be integrated across the landscape as part of a blue economy. But in every sense, we've got to adjust both sides of that equation. So obviously reintroducing coral into the ecosystem, but also repairing the ecological interactions that facilitate the success of those interventions, like repairing that herbivory and grazing pipeline as well.
Thank you. Yeah, thank you so much. I remember there's a photo of the doctor holding a very big crab. I was like, wow, that's really tremendous. It also showed that how the fruitful the biodiversity prospers in Florida Keys.
Thank you.
And my next question will go to Wing. Wing, from your perspective, how does the Delta Electronics Foundation work with heat resilient coral aligned with international biodiversity goals? And what kind of global collaboration do you foresee coming out of the COP16?
Delta is not a coral expert, actually. We always be challenged in our board meeting. I really know everything about the coral. That's why we need to try to consult with Professor Dai and other experts. Just think about what we can do from the private sector side. So in the beginning, we just try to recruit our volunteers, and especially they are all engineers. They'll give us lots of ideas. Sometimes you can call it crazy because show it on the YouTube. You have a different way to restore the coral, but we still need to consult I would say the real expert from the museum, like Mott or from the university, and try to find a way to do that. Then we will think about maybe our technology developed by Delta can help maybe some part of this restoration way. Just like Dr. John said, some companies will say, what should we do? Yeah, but because if every companies or every corporate foundation, they just do the same thing, just plant a tree, or I know now somebody just sell the corals like, if you restore coral, you just take maybe $100 US. Yeah, it's just like the greenwashing, something like that. But if you can do something that good and you really use your technology, like Delta can use our industrial automation things like the LED spectral dimming spectral systems or micro city, and maybe we have some contribution to the society, the research society. So I believe there will be a start, because actually we just don't know what we can do, and there's a lot of company around the world, and we are just one of many. But maybe this technology we developed is really good for the coral restoration, and we will try our best to do that. And then we will also try to mention that because people in the code system, people say it's the implementation code, and a lot of people talk about the biodiversity equity. Yeah, because they just try to make some. We won't say money. They just have some contribution finance part to support all the research society. But I believe this is also quite important for the company, because now they are required by different part of stakeholders. You have to prove that your business is not have some damage to the biodiversity. Even you have to prove that your business is good for the biodiversity, net positive impact. So I believe this was a chance. We hope we all have one goal, is to put like the 30-30 target, or to make the natural positive in 2050. If the goal is quite stable, quite clear, then we call it the public-private partnership. It can also happen in a ecosystem.
Thank you. Wait, hold on a second. I kind of want to ask the question all the way back. So keep the microphone to yourself. The coral reef, thank you so much for willing to mention that. And since you also mentioned about the biodiversity credit, so I want to ask you, how do we ensure the valuable coral reef ecosystem services are fully taken into account? Like, since the older business, are trying to quantify the ecosystem services, and what's your intake?
Actually, I don't know. Maybe this question is for the ICI. But we just try to do our best. Just as I mentioned, because we have do some coral restoration work for 4 years, cooperate with the different partners, researchers. But if there's some severe typhoon, just like hurricane and category 5, actually it will just wipe out all what you have done in the past 4 years, just for maybe 1 day. So actually it is very hard to do that, but for some adaptation job, you still have to do that. Otherwise, you just have no resilience works you can face to climate change. Just like today, everybody who want to go to this pavilion, you still have to cross the road. Yeah. I believe it's quite hard, but we just try to make it happen. Yeah, that's my answer.
Okay, so my next question will to both Professor Dai and Dr. Jason. So since we just mentioned about hurricane, and we know that this year there are 2 or 3 typhoon hit Taiwan, and also 2 or even more hurricane to hit Florida. I hope everything is also okay there. So how can the coral resilience or adaptation be improved against natural disaster like typhoon or hurricane, both in Taiwan and Florida?
Okay, yes. These are 2 major destructive forces for coral reefs. But the destructive force is not different. For El Nino, usually associated with heat waves, which is we should develop heat-resilient corals. For typhoons or hurricanes, basically it's induced by mechanical destruction or physical destruction. So in this part, we have to increase the healthy condition of corals, and where corals are strong, they can resist the impact from typhoons. For heat resilience, basically scientists are doing in different ways. Because when you look at a coral, it is composed three parts. The first part is coral polyps or coral tissue. Second part is symbiotic algae. And the third one is microbial community associated with these corals. These three parts both may contribute to the heat resilience of corals. So scientists are approaching these questions in different ways. But in any case, in practice, they have to do this through sexual or asexual reproduction, because we need to develop heat-resilient corals for next generation or the generations to come. So basically, they're selecting corals through asexual or sexual